Well, hello everybody, and welcome to this afternoon's track. It's a real pleasure to have you all here to listen to Kate and Maxine. Kate of eModNet, Maxine of Bioceanol, who are going to talk about ocean data, ocean services, and the work that they're doing in both those fields. My personal view is we're at a very, very interesting state in terms of gathering information about the seas and oceans. We've seen a growing interest in the public, the general public, in the need for data about the seas and oceans. Particularly younger generations are very concerned about what we've done to our ocean environment. Plastics are obviously very, very topical, but you can read it all the way through to climate change and all the events that we're beginning to see increasing rising sea levels, reduction in ice cap reports coming from Greenland, from the Arctic and from the Antarctic. And we're slowly but surely seeing a growth of understanding of the need to better appreciate what we've done to our seas and oceans. Now, with that comes the need for data capture. There are numerous ways of gathering data, and it's easy to think that it's easy to do. Actually, it's not. Our seas and oceans are absolutely enormous. And if I just use one example of bathymetry, we know it's a very commonly used statistic. We know more about the face of the moon and Mars than we know about our own seabeds. And I would argue that our oceans and our seas are inner space. They're largely unexplored. Very, very few people have been to the deepest parts of the seas and oceans, and there are countless aspects and characteristics of the deeper parts of the oceans that we don't understand. As important, shallower waters and our complex sea basins around countries like the UK and Northwest Europe and into the Mediterranean, the Arabian Gulf, South China Seas, all those areas are hugely complex human thoroughfares with a great need to understand the seas and the part of the world that they operate. But actually, the amount of data they have is not particularly significant. The other planets that are aligning are our technical planets. We can now capture huge amounts of data from space. You've all seen the stories that are flying around about low Earth orbit, CubeSats and the likes. That's going to transform how we gather data. It's going to transform how we share data and the timeliness in which that data can be obtained. And that data is more and more available to the common person. It's not just the restricted to governments, to militaries, to scientists. Everybody can access that data now. You just need to throw enough money at it. So it could be transformative for business as well. And we are most certainly going to have to protect and improve the seas and oceans and the environments, whilst at the same time extracting the socioeconomic benefits of exploiting the resources from them. Exploiting is an emotional term. Some people don't like it, but the fact remains we all need to eat protein. We all need the resources that are in and under the seas to support our lifestyles and the growing population that the Earth is developing. So we've got to get a symbiotic relationship between the two. So with no further ado, I think this can be done, but it will be difficult. There's a lot of work to be done, and be in no doubt as to how much data needs to be captured. I won't go any further with those opening remarks. I'd like now to give the floor to Kate Larkin of eModNet, the European Marine Observation and Data Network, who will share some of the very interesting activities and services that they've been developing. Thank you very much indeed for joining us. Kate, the floor is yours.
Great, thank you very much, Nick. So thank you very much all for joining this afternoon. My name is Kate Larkin. I'm the Deputy Head of the eModNet Secretariat. And today I'd just like to give you an overview of an oversight of the eModNet initiative, which is a long-term European initiative to deliver open source marine data and data products, all discoverable through various web and data services for the benefit of all, for the blue economy, for scientists and researchers, for governments and wider society. So I'll be giving you a flavour for some of the achievements that have been produced by eModNet over a decade since its initiation, and then giving you a little perspective of both the European partnerships and the global context of eModNet. So firstly, the question, why do marine data matter? Of course, many of you joining today are very aware of the need for this. It's an ocean conference, but nonetheless, it's important, I think, to remind ourselves that sound ocean data, not just any data, but good quality data, is really indispensable to tackle all of the major global issues that we have that relate to the ocean and the wider environment, but also to support the developing blue economy. There are huge projections for this area, and it's important that we create the opportunities for sustainable growth and operations, but at the same time being able to assess the good environmental status of these oceans so that the resources are there for the future also. And as I mentioned, it's not just data itself, but the quality of the data, but also how we can access it. So there are these FAIR principles to make sure that those data that are collected are not only accessible, but really findable and discoverable through many different areas that I will come on to. Interoperable, so they don't necessarily all have to be hosted in one place, but they must be able to talk to each other and be able to be discovered across different initiatives, and reusable. So having that rich information together with the data so that it can not just be collected and used once by one particular sector, but then made available for society to be used again and again in various contexts. So on the screen now, you can see just some of the examples of why we need access to marine data, and increasingly it's the rapid access as well. So it's not just the delayed mode data sets, but really the near real time, which of course has been solved in many ways in the physical parameters, such as temperature, salinity, and more, but is increasingly needed and made feasible through technological breakthroughs for biogeochemical parameters, and even verging on biological parameters as we go into the next decade. So this is something that's really exciting, because I think in the next decade, we'll really see more of a collective integrated ability to assess our ocean, both in delayed mode casting and hindcasting, but also in near real time and in forecasts and predictions. And just to remind ourselves that in Europe, at least, the cost of ocean observation is huge. We have, of course, a very good remote sensing program through the satellites, but also the in situ data that's collected in water with platforms, fixed point and various other remote platforms is a huge cost to both the nations themselves and the European Union. But this is seen as a really good investment because, as you know, a record that's not made is gone forever. So we really need to continue this timely and appropriate observation and data collection in our ocean. But there is a big question of how do you first coordinate all of these different data collection initiatives, and how do you then unlock the information that's coming from them and maximize the use of them, as I've mentioned. So in Europe, about 10 years ago, there were various initiatives that were set up to really go through the whole marine knowledge value chain and start unlocking this knowledge for society. So on the left hand of the screen, you can see the marine observations. That's where the data collection starts, and it's often called the upstream part of the value chain. And then there was this huge variety and capability in Europe for data management, but it wasn't really well connected. And so in 2009, the European Union set up eModNet, the European Multidisciplinary Observation and Data Network, to really start aggregating and put added value onto the in situ or the in-water data. In parallel, the Copernicus space program, which probably most of you are aware of, has been revolutionary really for the satellite and remotely sensed based data. And the Copernicus Marine Service is something that works very closely together with eModNet. Particularly now it has an in situ component, but it is still largely satellite. And this works very well as two complementary data initiatives and long-term supported by the European Union. And we have also the data collection framework for fisheries, of course, and Sea DataNet, which connects all the national data centres in Europe. So EMODnet has been part of this vision really for the European Union to connect data more and make it more usable, but very much in context and connection with the users. So on the right hand side, you can see the applications and innovation sectors, which can also be data providers, of course, but we see a huge diversity in sectors that would use marine data. And in EMODnet, we're always looking at these different tracks to see what types of data and data products are appropriate for these different sectors, and having that conversation so we can have feedback from their needs and requirements to feed back into the next phases and strategies of EMODnet. So together, EMODnet, Copernicus and the data collection framework are funded by the European Marine and Maritime Fund, and this delivers collectively the Marine Knowledge 2020. As you can see on the screen, it explains a little bit the vision that was set 10 years ago, and this is something that EMODnet has used as a framework to really deliver on, and I'll come on to some of the progress and achievements later, but to deliver the highest resolution possible in a digital seabed map, so bathymetric data, but also to complement that with topography, with geology and habitats and ecosystems, and then look at the upper overlying water column as well, and to have multi-parametric diverse marine environmental data on top of that. So EMODnet in a nutshell, as I mentioned, it's a long-term European Marine Knowledge Initiative, so it's a European Union initiative funded by DG Mare. The initiative is very broad and very diverse, as you will come to see. So it's really not just a marine data aggregator, but a marine knowledge broker. It's really collecting the data sets, working with those experts in data management and those experts that know the types of data products that are required, and then producing that added value and making it available in a very accessible way. And to achieve that, of course, needs a lot of people and experts. So we work with a huge network of organizations and wider community. As I mentioned, it's complementary to other long-term data services like Copernicus Marine. And the data products and data sets themselves are really focused on the in-water. So you can see from the surface to the seafloor over a wide variety of parameters, but the specialty really is on the in-water observations that can, of course, then validate and provide more rich data on the deep ocean and the seafloor, and different resolutions than the satellite data may be able to achieve on its own. We have the 7 thematic areas, a central portal and a data ingestion to really promote and incentivize data sharing, and the secretariat that I work for, which is part of the coordination team, to both technically assist and provide expertise, but also connect with the users, the stakeholder engagement and the science policy, and also with the, of course, international context as well. So an added value as well of EMODnet, there are, across all of the different thematic areas, there are data services for example, map viewers and ways to visualize the data and download the data, but also web services that really open the door to the fairness, or this open and free access to the data and the data products. So, for instance, the EMODnet is really setting the sort of marine domain standards in Europe for the in situ or the in-water data. And it really works towards these INSPIRE directive standards for geospatial data. It works towards these fair data principles. And the added value is that it's not just aggregating data, but really applying these standards and harmonizations to create these really integrated data sets from a huge variety of different data providers. But the metadata that describes that data really keeps track of the information. So it keeps track of who's produced the data flow, the provenance of that data, so that it can be used in a way from a sort of trusted source, but always acknowledging that original data provider. And then in terms of web services, these are being developed. You'll be able to see if you browse various options across the different thematics, but they're all working towards reaching the maximum capability so that data can be searchable, not only through metadata catalogs, but really using that to the advantage of machine-to-machine communication, so that really we can push the boundary of interoperability. And you can really discover and grab and pull in data from eModNet into various applications. And there's a link to the web service documentation, which gives you an overview of all of these services in more detail, with tutorials for applying them. So in a nutshell, the eModNet network has grown over these last 10 years to really connect quite disparate sectors that are providing data, and to really unlock them. So you would have had a situation before where maybe a data set would have had quite big holes in it in terms of the resolution or the spatial or temporal data sets. And then by bringing together these different sectors and by showing the win-win benefits of integrating these data, you can get a much better picture, which in the end will help not only for the management planning, but also the blue economy, as industries look for the baseline environmental data before they begin or during the operations at sea. So just to continue on that line in terms of the added value for eModNet, but with a more, say, blue economy or industry perspective, this idea of collecting data once but using many times really can have a positive impact for industry by bringing those data together in an integrated way, particularly baseline data that may no longer be needed for commercial purposes. It really can reduce the uncertainty and the risks and effectively the costs of operations, because industry can look and download and view baseline data before you start new operations to decide where to focus new surveys, for example, or where to complement and add value to existing ones. So it can really increase the productivity and add value and impact to the data that a particular provider has collected, because once it's in the eModNet system, it's always recognized, and then the impact can always be referred back to that data provider, but yet it's coming together with many other data providers to have a much bigger impact that can be used for high quality assessments, for example, in the World Ocean Assessments and in Marine Strategy Framework Directive assessments, etc. It also stimulates innovation, because once you have a lot of data integrated, you can then really push the boundaries with producing data products. And at eModNet, the expert network provide intermediate data products, which are designed to be used by multiple sectors, but then a business or an industry could access those data products or data sets and see how to tailor those specifically to a particular industry need. So it goes some way, but it doesn't do the full innovation, because that is for the blue economy and wider industry and other users to do that relevant to their needs. In terms of the breadth of eModNet, there are these 7 thematic areas that I mentioned earlier. And you can see the 6 sort of marine environmental, but in environmental parameters, including the seafloor as well. But then we also have human activities, which you can see at the bottom. That's the newest one over the last few years. And that is focused on human activity in and around the sea. So it includes blue economy, information, ranging from aquaculture and fisheries locations to renewable energy and shipping. And I'll come on to some examples later. And then in terms of the access, all these thematic areas have historically been funded separately. So that's why there are still these separate portals. However, they're all centrally accessible through the central portal of eModNet. And there is a progressive development underway to bring all of those portals collectively into the central portal, which means that right now you can search eModNet's central portal for all the data products, but in the next year or so, you will be able to search all of the data and all of the data products that eModNet has in its wide portfolio from this central portal, from a common map viewer. So I think this will be a really great development, because a user will be able to go to one place, select a particular area of the ocean they're interested in, and pick out all of the data and data products that they might be interested in to discover further. There's also, I should mention at the bottom, there's a link to tutorials which are being put on the eModNet video gallery. So if you have particular interest in a parameter or a portal, you can go there and learn more as to how to best use the data and web services. And just some examples of results of working together. So one example from each of the thematic areas before I go into some details. This is a lot of information, so I won't go through this, but it just shows the breadth of the data coverage per portal. And this is all available in a central catalogue for download. And then in terms of data products as well, you can see it ranges not just from maps, but also time series profiles and seabed habitat maps, for example, which I'll come on to. And that's a QR code to access that data portfolio with the link. So some of the highlights were the achievements. So in terms of bathymetry, back in 2016, there was the first release of a digital terrain model, but over the last few years, this has been improved. And in 2018, at the end of 2018, there was an advanced eModNet DTM release. And you can see that this now has a much higher resolution. This is approximately 115 by 115 meters, which as we know, the ocean has a huge scale, so this is actually a very good resolution going forward for the bathymetry. It can always do more, but this is really a leading product now in Europe. It has a 3D visualization functionality. It has expanded coverage, so it's not just the sort of close European seas, but also extending into the Arctic and the Barents Sea. And I should say that there's a collaboration with the Seabed 2030 initiative. So it's now a European contribution to that international initiative. And now there are satellite-derived data included in the DTM models. So this is Copernicus-derived satellite data, which is now incorporated in particular for the coastal areas where there may be more difficult to get high-resolution in situ bathymetry. And this is the international context that I mentioned, where there's an official memorandum of understanding now, and eModNet bathymetry is really looking in a global context to contribute to the international initiatives. In biology, this is where you would go for unlocking the marine biodiversity data. And there's also an atlas of marine life, which really brings together various research infrastructures and biological databases and e-infrastructures that are all working together now to provide the most comprehensive atlas where you can really search for different biological data sets. And again, in terms of the global context, eModNet biology is very well connected to the Ocean Biogeographic Information System and its European component, Eurobis. So eModNet biology actually collaborates very strongly and plays a pivotal role in contributing European data sets into OBIS. And these are used for international assessments, such as the UN World Ocean Assessment. And then if you were interested, for example, in more chemical data, including nutrients, contaminants, other pollutants, for example, chlorophyll data, oxygen, you would come to eModNet chemistry. And just to give you one example, there's now new data and data products on marine litter. And this was actually a huge effort. There's a lot of work behind the scenes to make the standards or the standardization of these marine litter data, both from beach litter and in water and on the sea floor. And this was really only possible through a synergy and active interaction together with regional sea conventions, with ICs and with various projects and initiatives, and facilitated and with a view to be used by the Marine Strategy Framework Directive assessments. Then in geology, there's an example from the map viewer where you can see eModNet Geology seabed substrate data is being used actively by marine spatial planners. And this is often really important to integrate data, not just from one parameter, but many, to get a view of how a region is used and how best to go forward in decision making. So this is being used by managers. And then in terms of human activity, I will skip to this one because if you remember in an earlier slide, we showed the vessel density tracking of human activities. That was on the slide where I mentioned about the benefits and the win-wins for industry. That was released last year, and that's now giving monthly composites of vessel density tracks across European seas. And when the COVID-19 pandemic was starting to unfold in March, eModNet Human Activities started tracking that and working with UMOFA to really see how vessel density would change, which of course would be expected to decrease with less activity, but it was very visible in these vessel density tracks. And the English Channel, which is shown, is just one of the examples. There are actually other areas of Europe which were more substantially affected. But you can see the difference between April of 2019 in the top and April 2020, where there's a reduction in activity over the same month of a parallel year. And these sorts of studies are ongoing because, of course, there will be impacts, potentially positive impacts to the marine environment because of this lack of or reduction in human activity. So this will be an interesting aspect that eModNet data and data products could facilitate. And in terms of eModNet physics, this is something that through collaborations together with Eurogoose and the Global Ocean Observing System, eModNet physics now can cover not just European seas, but a global coverage for a lot of its parameters. You can see a huge amount of global data sets that it offers for some of the sort of classic physical parameters, but it's also moving into other parameters such as noise as well. And it's through a collaboration with the Southern Ocean Observing System. eModNet Physics has actually offered a sort of mirror version of its data portal to this community as a sort of interface to share their own data. And that's been really revolutionary to offer them a central place to visualize and work on their data and share data. eModNet seabed habitats. This is probably one of the best examples of why we need to integrate data from different parameters. So eModNet seabed habitats aims to be the single access point for seabed habitat map information in Europe. It uses the EU CMAP and it has full coverage across European seas. And then if you see the different parameters and the different contributions of different eModNet thematic areas, you need geology for the substrate data, you need physics for the hydrodynamic energy, you need the habitat information and bathymetry together to look at the biological zone, and biology also. And then together you can produce this really integrated seabed habitat map, which can then be used by planners, by researchers, by industry to really assess which areas of the ocean would be most relevant potentially to avoid or to indeed position blue economy operations. But it also has this predictive capability so that even if original data are not collected yet or available, they can predict based on the habitats in an area where other very like habitats may be. And this is, as I said, the example of with these harmonized trusted data sets, you can really start bringing them together and produce integrated products, which can be used for various applications. Then in terms of who uses and benefits from eModNet, eModNet does track the metrics of the different users in terms of the number of visitors or unique visitors, the number of downloads, etc. And we do get a picture of the different sectors as well. But just to give you a flavor, you can see the different thematics and the central portal also listed in this graph. With the bathymetry, for example, you can see a big peak that was when the digital terrain model was initially released in the December of last year. And then, 2018, and then you can see the ups and downs of different data visitors, but this is only increasing and there's more information in the annual report of eModNet. And then in terms of the users, we have quite a few positive responses now from various users, including from the blue economy, that really say that they go to eModNet for their primary source for various information, including the bathymetry data and data products, which I mentioned earlier. Then in terms of where we're at with the data sharing, eModNet's obviously progressed very far in terms of connecting and aggregating data, but there's still a lot more data out there which is not yet in eModNet. And so this data ingestion service was set up to really capitalize on offering a service for any data provider who may not have the resources or the expertise or the time to manage their data and make it fair and open access. And data can be submitted to this central service where experts will work with the data provider to make sure that the information is describing the data correctly, and then it can be integrated progressively into the eModNet system and part of the integrated data sets. So it's become a very interesting service that's growing in its use, and we're seeing more private companies contacting and seeing the benefits of sharing their data with eModNet and with the wider community. And this is just an overview of the process of how it works. There is a lot of complexity in the different experts and organizations that eModNet works with, which just shows how much of an operation it is. But there is a steady data flow, and all data providers are encouraged to contact eModNet just to explore the possibilities. Then in terms of eModNet for the blue economy, of course, the data and the data products that are provided by eModNet, the hope is they will be used by many different sectors within the blue economy and beyond. And I've already mentioned some of the benefits to the blue economy of using eModNet. But I think it's important to stress that it's worth just going and investigating and exploring the wealth of data that is there already in eModNet, and seeing how it could improve the knowledge in blue economy operations, how it could add value to the data that's already available, and also the win-win benefits, because often data may be restricted, of course, for commercial purposes, but if in the original licensing, the data could perhaps be written in as after a certain period of time, it could be released and have a data flow directly to European initiatives or international initiatives such as eModNet, then that would, I think, help the data sharing from the beginning. And if it's written into the licensing as something after the commercial restrictions are released, then it's more likely to happen. eModNet also has an associated partnership scheme. So this is it was really set up for stakeholders, including industry, that were particularly interested in having a closer collaboration with eModNet, but they weren't a funded partner or didn't want something contractual. So this is a light, flexible framework and network which was set up and already has 23 members, mostly in the private sector and blue economy relevant sectors, but also university and research organizations and spin-off companies. So this is a way to have a closer dialogue with eModNet, where eModNet keeps these partners updated on the latest developments, but also they can feed back on data requirements into the future. And just some examples from the associated partners that are part of the network already. They see a huge value in gaining visibility really for their own work, but also connecting to these wider expert networks and to exchange ideas, best practices, data products, etc. And there's a lot of data sharing and data use then that can be discussed and optimized once a company has opened that dialogue a little bit more, and we're seeing more and more that the private sector are interested to see the options for sharing data. So this is just an overview of some of the different ways that associated partners can be involved. It's also, of course, of benefit to eModNet because it then connects the eModNet developments more directly with the blue economy. So it's a wider cooperation, but it's really then homing in on what will be the most targeted value for the blue economy. And then just to have a little look at some of the other users' opinions or some of the use cases. As I mentioned before, eModNet collaborates with the Copernicus Marine Service. And in this example, it's collaborating more on a river data service. So this is interesting because more and more society needs information on the coastal area and the land-sea interface. And this is one example through a project where Copernicus and eModNet data, so in situ and satellite data, have come together to really standardize and deliver more operational river data. Then in terms of eModNet chemistry, so this is more in terms of supporting the regulatory monitoring that needs to go on for Marine Strategy Framework Directive in Europe, for example, and also connected with the United Nations Environment Programme in the Mediterranean. This is a way that where the best practices for the harmonisation can really help to bring, as I mentioned before, a sort of marine domain expertise and standard for Europe to some of these discussions, and that's hugely valuable for different nations and cross, transnational discussions and assessments as well. And then bathymetry and geology data in terms of geomorphological mapping. We have users, including the International Marine and Dredging Consultants, which specifically reached out to say how much they value the high resolution and quality data that's accessible for bathymetry in Europe. So this is just one more example. And then one from Cathy Associates, where the human activities database of eModNet has become really important as a source of different data on human activities, but also in terms of the positioning and location of different blue economy operations, which can then inform new pipeline developments. And that's a link to the further use cases of eModNet and testimonials. And then just as I reach near the end of the presentation, eModNet very recently celebrated a decade. So the annual report of 2019 celebrates that. There was due to be a open conference in September of this year, but that has been moved to June of next year. But we did have a webinar on the 22nd of September, and that's available to watch. And a short documentary film which celebrates eModNet 10 years in 10 minutes. And then in terms of the international collaborations, I just wanted to highlight that, of course, we work very strongly across European partners, but this is in the context of the global ocean. There are specific projects in different regions and then at the global level. So there is a collaboration between Europe and China, the eModPace project, which started earlier this year and is looking into interoperability of data between the EU and China. And then there's a lot of connections through to the IODE of IOC and how eModNet can contribute to the United Nations Decade of Ocean Science and to the Sustainable Development Goals. And in terms of the IODE, the International Oceanographic Data and Information Exchange, there is a developing relationship there, and eModNet has been nominated as a European contributor to an upcoming initiative called the IOC Ocean Info Hub project, and this will see much more data sharing and interoperability of marine data at the global level, but based on different regional hubs and focal points. So in terms of the decade of progress that I've shown some highlights, we're now looking towards the next phase, of course, the next decade, which is so pivotal really for the ocean and the wider environment. So eModNet is well placed to deliver data and data products for that. And we would really welcome as many of you as possible to join us at the Open Conference next year in Ostend in Belgium, which is where I'm calling from today, where we will really listen and have feedback from data providers and users, and to see where where the best focal areas are for eModNet in the coming decade. And that just leaves me to thank you on behalf of the whole eModNet network, the Secretariat, and all of the experts involved, and various links to follow up with us if you'd like to receive more information or connect with us so that we can share our regular news updates. Thank you very much.
Thank you very much indeed. Do take a quick swig of water before I start hitting you with some questions, because I will ask you one or two questions specific to your presentations, if I may. I love that presentation. I had my first presentation on eModNet when I became the UK National Hydrographer back in 2010. And my goodness, it has come on in leaps and bounds since then. A very impressive, very comprehensive approach. And I just love the way you've linked it with the blue economy. You've touched many themes that I often comment on. You've very strong blue economy theme in there, very strong socioeconomic, environmental coverage, very strong coverage of complex sea basins. And I love the way it's linked to the wider blue growth policy of the European Union. And you particularly made the point about the land-sea interface, where quite often that is a boundary. It's a sort of cultural and a psychological boundary, whereas actually it's one of the most important parts of any country and its interface with the sea is that coastline where the bulk of the world's population lives. So I just love that presentation. Thank you very much indeed, and well done to you all for what you've achieved. You showed many slides of the geography of the coverage, if you like, of eModNet, and it clearly flexes. Obviously, the bulk of it is around the European Union and the complex sea basins of the European Union. But you also went to the Arctic and you went out into the wider oceans. Could you give a sense of the global coverage? Because you obviously have a global capability. Clearly, it's not going to be completely global. But if I say I was working, well, we are working in the Philippines at the moment, say I had a data set from the Philippines, would that be something that would be ingested into eModNet, for example?
Thanks for the question. So the last decade of the progress that I showed, the vision and the sort of commitment or the priority, if you like, has been on the European seas. So that's why we see such a good coverage now across various parameters in that geographical area. However, now we're looking to the future. We've already got examples where there is either global coverage or various regions where there's increasing coverage beyond Europe. So any data set that would like to be shared or ingested in eModNet could be. However, on that note, we also have good partnerships across different data initiatives across different regions. And so I would say that if there are data providers in different regions of the world, they could also explore opportunities with their own region initially, but with ones that are connected and interoperable with eModNet. So I think the plan going forward is that, yes, of course, there would be never a case of turning down any data that would like to be shared, but it may be more appropriate to initially share it with a national or regional data center, and then we could have that conversation to partner with it and make it interoperable and then accessible through eModNet in that way. And I think that's the sort of way that the discussions go at the international level with the IODE as well, to maximize on regional capabilities. And in Europe, eModNet is one of the leaders in that realm, and then to really connect those and make those interoperable so that we don't have a process of setting up lots of new data portals in the future, but we have at least overarching platforms that can discover data all from anywhere in the world that has web services with APIs that can grab the data, basically.
Very good. Now, I did spark on the slide where you showed usage of the database, and impressive numbers there. But I was not as many as I thought, perhaps, and presumably there's a growth in use. How well known is eModNet? Are you seeing a continuous growth in use? Do you expect to see it extend? And what might be the barriers? What's the challenges of getting people to use this data set or to contribute to it?
Yes, so indeed, the metrics that we showed were sort of unique users that would come, and we're seeing a steady increase in unique users, but also there's many regular users which would come back and wouldn't feature maybe in those metrics. It's interesting that the types of users is diversifying. So it's really in the first few years of eModNet, it was really much more the marine research community, I would say, that would go there and use it. But progressively, we're seeing more and more interest from industry, from the private sector, that will visit and start downloading and use the information. And I think some of the barriers is sometimes just the effort to make it people aware of it. So, for example, there was a recent meeting that we presented eModNet to various industry, predominantly the aquaculture industry. And some of these are quite small, medium enterprises, and they may be, they have enough on their plates doing their own operations and business, and they're just not aware of the opportunities to connect their data and the services that are on offer to assist with that data sharing. So it's not, the onus is not on the data provider necessarily to do a huge amount of work to share the data, but really just to know about it, reach out, and then work with experts through eModNet to make that data more accessible. So I think some of those are sort of communication issues, but we're working very closely, of course, with the European Commission, with Copernicus Marine as well, because both data initiatives have a lot to offer and can do a sort of combined package in some ways to the private sector as well. So I think that's increasing. We are seeing a lot more interest, but a lot of it is proactively going out to those different sectors and communities and opening up the dialogue so that people are more aware of eModNet beyond the classic, marine or technical experts.
Very good. And I'm going to ask two more questions, and the last one will be the Brexit question. So I'll give you a warning before we give Maxime the floor. The next question really is around technology, and as people bring in wacky new ideas for data capture, my company, NLA International, for example, is working with a company that has created a power generation capability in buoys that go up and down the water column using the temperature differential. Is eModNet the place to come to seek advice on how that type of asset might be used? Is eModNet a potential partner? Do you incentivize people to gather data and in an imaginative, innovative way to come into the database?
So eModNet, initially in this sort of first decade, it's been set up to really connect and aggregate the data, but we're always looking to connect across the whole marine knowledge value chain. So it's really important, I think, if there are new developments in platforms, in sensors, in parameters, to yes, reach out and have that dialogue with eModNet, because then we can see, even before data might be operational, how it could fit into the different thematic portals of eModNet, maybe advise on the formats of data collection and standardization and processes. And eModNet can also advise on which either national data centers or various services would be available to then make that data available and plugged into the near real-time delivery as well, which is increasingly important. So yes, we've done that with industry. For example, with Saildrone recently, or at the end of last year into this year, we worked with them in a partnership together with Copernicus and the ICOS International Carbon Observing System to deliver their data on physics and biogeochemical operation data into the eModNet and Copernicus platforms in near real time. So you could see the track coming into the Mediterranean Sea. So we can do those sorts of operational deliveries, as well as then the back-end data management to bring it into the integrated data sets.
Thank you very much indeed. That's really interesting. So the final question, and this is a mixture of quality, what needs to be done, and what about Brexit question. You've talked about the decade, and I'm going to go away and watch the video after this. And I've already got in my diary the date for next year's open conference. So you've obviously got my attention. Could you talk a little bit about what sort of percentage of the, it's a really difficult question this, but what sort of percentage do you think you've achieved? So I mentioned we know more about the face of the moon and Mars than we do about the seas and oceans. I can tell you that we've still got 80 to 85% of the seabeds to map to a modern standard. So do you think you've got 50% left to go, or 30%? What progress are you making? What quality is it? And how might that improve, or does it need to improve? And then the final one is the dreaded Brexit question, because clearly in many of the case studies you showed, the UK and its EEZ is a key part of your coverage. And I do think you're confident to be able to put arrangements in place to keep that information flowing and to share information to the benefit of everybody. Sorry, a bit of a jumble of questions for the final one.
Well, in terms of coverage, what I'd say is that it's very dependent on the parameter, because of course, as you can imagine, physical data, as I mentioned, a lot of the technological breakthroughs had already happened nearly 10 years ago in terms of near real-time delivery and the cost of the sensors involved. So in that sense, the physical coverage is much higher than maybe some of the biological parameters, which require active surveys or sampling of the environment or the seafloor and looking into the organisms that are there, which takes a lot more time to process as well as cost to sample. So in that perspective, I think there is you're never going to have the sort of full resolution. I think the important thing is that the data gaps and requirements, that we work with the users to really define where those gaps and requirements might be, because of course the ocean is huge and we can't always cover everything. But if we can work with sort of feedback from the users, that if there's a particular area or particular parameters of interest, we can work then with the ocean observing and data collection and monitoring communities to make that loop and to make the focus or the priorities go into those areas. And that's across private and public sectors that would be needed. So the European Union has actually called recently for stakeholders to consider this more coordinated approach. There's actually a survey that will have finished by the time this is broadcast, but there will be further consultations where stakeholders will be invited to see how it would be appropriate to incentivize data collectors to really work and collaborate more together, so that we're reducing duplication of effort of sampling and maximizing the new data that's provided, so we can push those resolutions and those spatial coverages more. But I think in terms of Europe, eModNet's obviously progressed very far in terms of the bathymetric resolutions, in terms of physical data, and we're now seeing much more broad and diverse parameters in the more biological parameters than we've had before. So I think it's the next decade will push those boundaries much further. But I'd really like to see that once eModNet and others around the world are connected, I think we might be able to really fully see the full coverage across the globe, and that will be very impressive, but there will be big gaps still. So the job is definitely not yet done. Brexit. So in terms of the operations of eModNet, it's business as usual. So European eModNet as an initiative will welcome data from any European seas and oceans. So there's absolutely no issue there. And we have very strong partnerships and collaborations with UK national data centres and various sectors of data providers and users. There is expertise that we work very closely with in the UK, for example, the JNCC, Joint Nature Conservation Committee in the UK for the eModNet seabed habitats. But this is part of a wider consortium and a network of experts. And so we're working very closely with them, and that will continue despite Brexit. And I don't see any other ways that it will really profoundly affect, because in the end, eModNet is providing free and open access to data, so it's not in any way affected by that. We just welcome all data providers and users to come and see the services.
That's a great answer, and I'm sorry about the question. It stands out a bit, and very encouraging answer actually. I think actually, thank goodness, we're all passionate about the seas and ocean page. It would be madness not to. Thank you so much for a really good presentation, Kate. Do take a bit of a breather while we listen to Maxime, and then we can have some more questions in a panel session. So, ladies and gentlemen, it's now my pleasure to introduce Maxime Lafont, Chief Technical Officer of Oceanal. And you heard Kate referring to aquaculture and the work that eModNet have been doing with aquaculture on the provision of data. And I know that Maxime was very interested in data for aquaculture. So Maxime, with no further ado, the floor is yours, and thank you very much.
Thanks a lot, and I'm very glad to be a presenter of today's session about ICT and AI to predict ocean water quality. And as you mentioned, and as Kate mentioned, my presentation will specifically focus on aquaculture. So I'm Maxime Paris. I'm the CTO of Oceanology, as you mentioned, and you will be able to find more information on our website at the end of the presentation at bioceanol.com. So Bioceanol is a French company based in the south of France, in Sophia Antipolis, is a French Riviera, and we are working in different areas for monitoring and for artificial intelligence for water quality. So we work with different areas for environmental connectivity and also for aquaculture applications. And our team is composed about more than 20 people, including biologists, data scientists, and also some IoT engineers. So today I will discuss about the ICT and AI to predict ocean and water quality, especially for aquaculture. And first of all, I will present to you some aquaculture trends figure, and then I will talk about what is aquaculture monitoring now, and what we want to see in the future. And because thinking about ICT and AI, I will present that and do a quick overview about what exactly is IoT and AI, what we have in mind for aquaculture. And then I will present different use cases. It's important, I think, to have some use cases about exactly what the use of IoT and AI in aquaculture, and I will do that through the angle of high-value continuous information use case, with safe and reliable data use case, and then with the sustainability. So let's start with the aquaculture trends. So a few weeks ago, the FAO released the biannual report on the state of world fisheries in aquaculture, so that we call also SOFIA. And I wanted to take some time to talk about the information that emerged from this report. First of all, seafood consumption has reached 20.5 kilograms per person per year in 2018, and it has grown of 3 to 1% per year since the 60s. So that's really huge. And seafood remains the main protein coming from the sea, and it figures at 52% of the consumption. So it has never stopped progressing, and it's estimated that it will reach 59% in 10 years. So it can be explained by the volume of the production by aquaculture that has grown by 25% since the last decade, as compared to the fisheries that has only grown of 7%. So all this information confirms that year and year after year, that aquaculture is an exponentially growing sector. So that's why digitalization must happen at some point, and that have best practices to be able to allow the lowest environmental impact as possible. So as we mentioned, environmental impact, the keywords and title of SOFIA 2020 is sustainability in action. So fisheries sustainability must be achieved at higher levels, but also aquaculture sustainability, which is as important as fisheries. So this sustainability preoccupations are part of the United Nations Sustainable Development Goal, and especially of the Goal 14. So yes, increasing sustainability is possible, but it will be achieved only with a good water quality monitoring and a precise farm management. So now let's talk about how aquaculture monitoring is done. So what do we see now in aquaculture? Too often we observe analog aquaculture management. Data is gathered by hand, sometimes only once a day or never, sometimes in open sea. Data can be lost or untraceable, and in this case, it loses all its value. So this kind of aquaculture management is totally imprecise and does not have any real-time capability, and the traceability is really low. So another observation that we do in aquaculture is the imprecise feeding. So farmers give manually scoops of feed into cages, and that's a reality. And it can lead to environmental pollutions because all the fed get lost outside of the cages. So also the large amount of food is wasted, and the farmer in fact lose a lot of money and to the uneaten food. So with this imprecise feeding, fish growth is not well controlled because feeding time and quantity is not adapted to the reality, and the animal appetite can lead to disastrous consequences in the ocean, in some specific area close to the cages. For example, it can lead to some phenomenon that we observe more and more frequently since a few decades, that the macroalgae blooms. This event can occur when all the environmental conditions are met for the optimum of growth of the macroalgae. So therefore, the growth exponentially and blooms in few hours. So the macroalgae produce oxygen during the day, but also consume it during the night. That's such a big problem for the aquaculture. Some species can be highly toxic for animals, and in fact for the end consumers that are human. And at the frequency that the bloom appear, it can deplete the ecosystem durably. After that, we see some macroalgae blooms over the years, and too many farmers are helpless in the face of these blooms. So now, what do we want to see in aquaculture? So we want to see digital aquaculture management with real-time and precise monitoring. We want to see all the information that we can gather precisely and immediately. We want to be sure that the data is accurate. That's something really important. We want to be certain that data is never lost and always reusable. But most importantly, we want to be able to use the data efficiently to provide added value, in fact. So to provide advices, to anticipate issues, to improve and learn from the past, to help to digital aquaculture management that can give a powerful tools to better production for a farmer. We also want to see, we also want to see some smart feeding. We want to see feeding practices with less impact in the environment. With a smart, accurate, ultra-specific feeding plan, money can be saved in this case, and production can be optimized and growth can be specifically predicted. Regarding the macroalgae blooms, we don't have any farmer, we don't want any farmer to face it when it's too late. So we want farmers to be notified when and where a bloom can occur. With this anticipation, farmers can take action. They can harvest sooner if it's possible from the fish. And if it's possible, it will allow them to avoid losing a lot of money. All of it is now possible with the digitalization of the practices. So now I would like to take a few time just to explain what is IoT and AI. So IoT stands for Internet of Things. Why do we call it Internet of Things? Because there is a lot of objects that connect themselves to internet, gather and send their data with no human interaction. Everybody knows those objects. So for example, a watch that calculates as a daily footstep is an IoT service. A camera that protects your home and sends alerts to the police is an IoT service. Smartphone, television, humidity sensor, even a car can be now an IoT service. So in 2019, 26 billion of IoT devices were connected to internet. 127 new devices are connecting every second worldwide. So the world of connectivity is part of our world. So what about Internet of Things in aquaculture? It's time now that we use the IoT technology for aquaculture and for ocean. Imagine a fish farm where sensors are deployed everywhere, in the fish cage, on the fish cage, outside the fish cage, on the boat, on the management house. So imagine what does it mean? It means that fish farmer can get remotely, instantly, and continuously information about fish production status, cage status, water quality inside and outside the cage, feeding status, boat capacity, and maintenance status. This is a whole new world of efficiency that's open for farmers, and that's really important. The IoT technology, does not only provide connected sensor. Because it is designed that way, it provides security and also a long-term storage capability. In this case, data is not lost and cannot be stolen. Now you probably have heard about big data, but what exactly big data means? So to truly understand our new and trendy terms, you need to realize that every 2 years, we create in the world as much data as we did from the beginning of the humanity until 2003. So every 2 days, for example, 300 hours of video are uploaded on YouTube every minute. 1 trillion of photos are taken and shared every year. 40,000 search queries are performed on Google every second. So big data only means that we are in the era of information. With all these connected devices and high-speed internet capacities, we produce massive amounts of information. And that is also true for aquaculture. Let's go back to our fish farm, where sensors are deployed everywhere. So we can get a lot of data, time series data, graph, alerts, status, comparison data, forecast, images, and video. We are very happy to gather all this information, but what to do with it? Is it too much? Do we need to throw all this data because we are overwhelmed with it? Because we don't know how to analyze and to extract the potential of it? Hopefully, no. Even if it's true that today less than 0.5% of all the data is ever analyzed and used, with big data and new technologies also appear artificial intelligence. So artificial intelligence is the ability of a computer program or a machine to think and learn. Computer systems with AI are able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages, for example. For aquaculture, artificial intelligence will be a big help. Our connected fish farm with all its sensors will truly unleash its potential. It will be possible to have analysis that is always adapting and learning, to have multi-parameter comparison in seconds, to have parameter forecast for a better anticipation, to add outside data like weather forecast and satellite imaging, as Kate mentioned earlier. All of this combined will give ultra-specific advices because there are no two identical farms. So each farm is unique with its unique environmental conditions, management practices, and of course with production yield. So this is why digitalized aquaculture must happen and is happening now. So I hope that you have a good point of now of what is IoT and AI and how we can help on aquaculture. So let me give some concrete example and use cases of IoT and AI for aquaculture. This use case I will present in three categories, with high value continuous information with some parameter monitoring, with safe and reliable data with data traceability and decalibration detection, and also, and I will finish with a sustainability with a certification optimization. So let's start with the high value continuous information use cases. So the first parameter I wanted to show is the oxygen. Of course, oxygen is one of the most important parameters that every farmer has to monitor. Here is an example of a daily oxygen monitoring. So with this data, we can see that oxygen is always good and quite stable. That's interesting, and we can see that no issue is detecting and no action is taken. The oxygen measuring is quite stable. So let's see about what happens when it's a continuous monitoring data. So with continuous monitoring, we can see that the reality is not the same. Oxygen is varying a lot and even get very low during the night. This is a normal biological process. Those sorry for that. Those ups and downs are actually are not an issue. However, we need to control the amplitude of these ups and downs and to be sure that the oxygen is not getting too low, because too low oxygen, even for a short period of time, is stressful for aquatic organisms. And of course, too low oxygen for a long period can cause total death and be dramatic for the environment. So having this information can help a farmer to take some action, reduce the stress and the mortality, and to protect, in fact, his farm. Although with this parameter, the feeding can be adapted to the oxygen level. That continuous information can allow to identify the worst period, here in red, and the best period for feeding the, feeding the fish. That is a concrete example of continuous monitoring for a parameter in the case of aquaculture. Moreover, with AI, we are even able to predict the evolution of the oxygen in the next hour. That's something that biologists and R have done. It's very important that to be able to anticipate the oxygen depletion. So here you can find an oxygen forecast curve in blue compared to the real value in black. So as you can imagine, this is a powerful alert that we can give to our farmers. They will be able to take decision and action before the problem occurs. And this is in this particular context with social distancing issue and changes in different jobs due to COVID-19 crisis, it's even more powerful tool because it's allows farmer manager to adapt efficiently the team planning to the reality and at a distance from the ocean and from the farm, sorry. Another parameter, temperature. It seems to be a very simple parameter to follow. However, it's also a high value information when it's continuously monitored. For example, some microorganisms can grow only in some optimum temperature. Therefore, an alert can be raised for the oyster farmer when the risk of bacteria proliferation is high, for example. Another example is the optimal temperature range for Atlantic salmon is between 8 and 14 degrees, but they can also develop well up to 18 degrees. Therefore, in Chile, there is natural competitive advantage with an average temperature of 12 degrees, and the production is few months shorter than any other salmon production region with lower average temperature. So connecting the data massively gives a strategic advantage to a farmer. Sorry for the cough. So let's talk about turbidity now. So turbidity is water's transparency. So a variation of turbidity in the water can directly influence the biological processes like behavior or feed intake and other parameters such as microbes. So turbidity can also influence the quality of animals' filters, such as like oysters, for example. So the advice for oyster farmer is to adapt the best harvest strategy with the turbidity monitoring, and for the fish and or shrimp farm to adapt the best bacterial cure, for example. Those were examples from advantage of continuous monitoring. But now our second series of use case with about safe and reliable data. So traceability of the data is a big importance to the digitalization of aquaculture. Without traceability, there is no valuable data. So what does traceability mean? It means that we always keep track on the data. No data loss, no data with no idea where does it come from, and data is always valued and protected in that way. It also means that with a good traceability, it is possible to automatically compare each month or each quarter or each year and learn from it to improve each time. Also, all the problems that can occur in the production is monitored and stored. So it's always possible to come back, analyze it, understand, and to adapt. So the data will also be always secured and protected. All type of production can improve their practices continuously by always learn from the past. Interoperability of data is also really important as we need data to be usable everywhere. For that, Oceanology is a part of the European reflection group that is called Aquacloud to help to harmonize all the different data in aquaculture. Here, I will talk about the decalibration. As you may know, a sensor image into water will have a drift of its measure over time. So it's normal effect, no worries, even if we try to reduce that drift as much as possible with better technology. AI algorithm can detect the decalibration. This is something that we have developed. On this demand, recalibration is a huge step to save money, to save time, and always have accurate data. Recalibrations that are made every month, for example, have two disadvantages. First, losing time with all sensors recalibration, even if you're not sure if it's decalibrated or not. And secondly, doing the recalibration too late will lead to no accurate data. So decalibration detection allows to save time with on-demand recalibration and to always get accurate data. This is something that we have developed and that we propose to our customers. Let's talk now about sustainability. So we believe that sustainability can be better achieved with certification. Ocean Aquaculture Label provide checklists to be filled in order to obtain the certification. After that, information has to be sent periodically to be sure that all the targets are fulfilled. Having the digitalized aquaculture monitoring helps to save for certification with historical and traceable data monitoring reports, especially for environmental data. So with the digitalized processes, we help farmers to keep into the required thresholds, and actually experience showed that the more closely they monitor the water parameter, the more they learn and adapt. With time, their water quality stay in the required zone more often. So I hope that those use cases were interesting for you, and I give you a concrete example of on ocean successful digitalization under the example of aquaculture. And to conclude this presentation, I will present for you the main following steps to monitor the aquaculture, and that will able to give advantage to ICT and AI in the future, and especially for the ocean. So to be able to open the ocean and the world to the data recovery, we are working on different ways. First, to allow data collection all around the world. So not only from the coast, but also in isolated areas such as island for the continuous monitoring. So this step will allow to have an overview and precise data from all around the world. Those evolutions will allow the continuous analysis of data and permit users to use the data to answer some specific questions through machine learning and big data analysis. The development of specific model will participate to the better understanding of the ocean and understand phenomena that we were previously poorly understood. Thank you very much for listening. Sorry for my cough. And I hope that you enjoyed this presentation. And if you want to learn more about what we do, you can find more information on our website.
I thought that was a really good presentation. Thank you very much indeed, Maxime. I learned a hell of a lot, and it also corroborated much of the work that we've done recently. I've got a couple of questions for you, and then what we'll do is just sort of roll it into, for the last 20 minutes, into a conversation that brings Kate in as well. So to start with, could you just talk, I love the vision of the totally connected fish farms. We've been talking about smart connected fish farms for a long time, digitization of aquaculture. I love your vision. I love the graphics which showed that. But when I go and talk to Jason, a chap on the western side of the Shetland Islands, and say, I want you to do this with your mussel farm, the first thing I know he'll say to me, because he did, was, where am I going to get the money for that? How do I make this fit my business model? So for a shellfish farmer with, say, 9 or 10 locations, have you thought through how your concept can be built into his or her business model so that they can drive efficiencies and improve their bottom line and improve their profit, please?
So just to be sure, you had a question about how is it possible to adapt our system for a different area and specifically for a different kind of farm, right?
It's to make, how can you make it affordable? Because that's a lot of technology. Quite often the fish farm is in a remote location, connectivity is poor, margins can be tight. So how can they afford to install that level of technology?
Yes, we have built, we integrate different kind of technologies thanks to the IoT. The first one is the LoRaWAN technology. that kind of technology uses radio wave communication. This is a quite cheap technology that allow the communication from a diameter of 10 kilometers from the coast. That's good, but that's not enough. And what we have done, it is a satellite communication. We have integrated in our produce Iridium technology to be able to monitor and to get all the data from all around the world. We are working yet in French Polynesia, where there is quite no communication, no internet, in fact. And in those cases, we use Iridium technology for the satellite communication.
Okay, thank you very much indeed. And so that was for in situ established fish farms. Looking to the future, we are beginning to hear more and more about fish farms going further offshore, more into the oceans. Do you see the opportunity to use your vision and your technologies to gather data about the likely locations of these fish farms before you install a fish farm? So you can say, I think this area is better to build a fish farm because I've monitored it for a while and I can see the value of that water column for fish farming.
Yes, exactly. And that's a really interesting question, because it's exactly something we already do. We have different customers that want to have a fish farm or an oyster farm, as you mentioned, or in fact having some pump in a specific area, and they just want to find the best. And having those kind of information about the physical, chemical parameters coupled with different other information such as environmental data, such as wind, high wave, things like that, is really helpful for farmers, because they can get some information before the installation on the site. That's something that we already do, and in this way, what we do is the deployment of different IoT devices in the area, and to be able to find the best place.
Thank you. And Kate, I guess, I imagine you would be quite excited about getting your hands on the sorts of data sets that were described by Maxime in that comprehensive approach to gathering data from digitized fish.
Yes, absolutely. So eModNet is already having some dialogue with aquaculture industry and data providers, but I think this is an increasing area. We've seen in that dialogue that there is interest and motivation to share data, and sometimes it's just a case of communicating that and opening that dialogue. But there are huge possibilities, I think, as a win-win for the aquaculture industries as well, because if they potentially could share some of the baseline marine environmental data that they're taking around their local farms and share that with the bigger picture, then there could be a nice regional perspective that could give, I think, some more information and potentially even early warning signs and predictions of various parameters changing or harmful algal blooms, etc. So I think it could be a very interesting track to explore.
It's just so synergistic, isn't it? It's so obvious when you talk about it. But Maxime, do you think we need to digitize wild capture fishing? Do you think that the traditional wild capture fisheries are sufficiently digitized yet? And do you think there's a relationship to be had between aquaculture and wild fisheries?
That's a really interesting question. Yes. The word fisheries is decreasing is totally decreasing now, and aquaculture is increasing. Why aquaculture is decreasing? Aquaculture have to be more efficient, more sustainable, and produce more and more. And in my opinion, that the way that aquaculture have to integrate those kind of tools, it's if it don't do it, I think aquaculture will die, or will be just quite stable only, and will be impossible to grow up. So it can be good and interesting to use this kind of tools and to be able to track for the fisheries. It can help in the framework of to find the best location for the fisheries. It can be good in this way, and And I think this is mostly an advantage for the aquaculture than the fisheries.
Yeah, a good answer. I mean, my sense of this, I don't know what you think, Kate, is that traditional fisherwomen tend to be very protective of their data, and they don't want to share data. You know, if I give away where I'm fishing, then everybody else will come over and fish. Have you found it difficult to obtain fishing data from fisheries?
Yes, this is something really specific, because the data from the production, data from the capture, data from directly from a farmer or from fishermen or women, is something that is quite protected by the owner. And it raises an interesting question about who is the owner of the data. If it's you are the own producer of the data because you have fishing 10,000 tons of fish, that's your own personal information. But what about the question about the information about the water, information about the environment where you are doing your activities, you are doing your fisheries, you are doing your farm, your aquaculture? And that's a question that I do not have the answer yet. So in our opinion, the owner of the data is the user. We work with a lot with farmer, and in our opinion, farmer are the owner of the data. And for that, it's interesting, and we are able and we want to share the data, because as Kate mentioned, it can be a win-win program to be able to share the data, because companies such as ours and some others company will be mainly interesting about using the data and get a lot of information to be adapted and to help themselves. But that mainly raise the question about who is the owner of the data. And I think this is a common question from the Europe and from all around the world.
Yeah, so that's really interesting, isn't it? And Kate, do you, because I just see synergies here with offshore renewable energy. You know, why don't we combine aquaculture and offshore renewable energy? We're going to restrict fishing areas by putting in wind farms. So what about if we put aquaculture in amongst wind farms? And do you think there'd be a big take up with the sorts of data sets that Maxime is talking about by the renewable sectors? Can you see those sorts of synergies happening?
Yes, I can see that's a really interesting question, and also links very well with developments, because I think in the future, you know, ocean space is limited. We have to really see how best to use it. There's a lot of good data out there, but I don't see yet that people are integrating that data to its best potential. And nations are providing their own marine spatial plans. In Europe, I believe by early next year, there is a commitment to do so. And so the eModNet Human Activities is working closely to see how eModNet could best support the delivery of those plans, but also, you know, into the future. It's a very interesting idea to see how to link various blue economy sectors together. There are some examples of, you know, wind farms and others that would have marine environmental sensors on platforms and profiles in combination, and potentially with aquaculture as well. So I think this is really interesting, and this is where you would need the near real-time access to multiple parameters, because there'll be multiple sectors needing those data for different operations. So I think that is the sort of future. And as I was hearing Maxime talk about big data as well, I think it's really interesting that in some parameters we're basically nearly there, or we are there in terms of creating big volumes of this big data, but other parameters were really just the tip of the iceberg of what could be achieved for more biogeochemical or biological. And it's important as we scale up that it's not just the volume of data, but the sort of structured approach to this traceability that Maxime mentioned. This I think they have various V's to the big data, including the volume, but the veracity as well. So the accuracy, the traceability of this data is hugely important. And I think we're all signed up to that, but I think it's difficult to do in practice, and it cannot be underestimated how much you the metadata, the processing of the data, and the trusted approach and the provenance of this data is to ultimately be used. Because if we get to a situation where many different sectors are needing data, maybe for regulatory processes and procedures and their own operations, this puts another level of the need for the highest quality and delivery of the data as possible. And you wouldn't want a sort of data lake or data pool where all the data is together, but you don't know that quality because it just won't be used. So I think that's a big challenge, but it's an exciting one as we move into this digital age where the technology and the capability is there, but you need that marine domain expertise very much with the technology to make the data really worthwhile and indispensable, like I said in my talk.
You just touched on something which is always interesting, because you basically saying that the data's got to be very high quality collected properly, etc., etc. How far do you think scientists are perhaps being a bit hard over on this? Because I know, for example, that there's research now of ship's logs from the 1800s, Nelson's day, to look at the weather then and the weather we have now. Now, those guys were not trained meteorologists. They were just naval officers on a sailing ship, and they recorded wind speed and direction and the rest of it. And we're using those data sets today. So is there a danger of demanding too high a standard and therefore losing out on some data sets which would have a value?
So do you want me to start?
That was to Kate. Do you want Maxime to have a go at that? Okay, it was you, Kate.
No.
That was the please, either of you.
Go on, Kate, and after I make a comment.
Okay. So I think, of course, historical data is hugely valuable, and I think we're realizing how valuable it is. In terms of, new data collection, I think the most important thing is coming up with some minimum requirements of standards so that at least data can be then brought together. Now that it's a much more complex system with many different sectors wanting to collect data, especially we move into citizens that are becoming much more engaged, and they're wanting to engage in citizen science projects, both actively collecting or maybe assessing data outputs or model outputs. So we're getting to the stage where we really need to set more of these standard approaches to make the data usable. But I think the historical data set that's hugely valuable, can be brought into current use as well. But we need to make sure that the future data sets are well standardized to really maximize, because it's very different going from maybe physical data sets to the much more complex biological ones, which maybe need a bit more thought into the requirements.
Thank you. Max.
Yes, I totally agree with you. It's something I wanted to say exactly the same. And I just want to mention that the comparison is, in my opinion, is not the same, because by Oceanology we are some user of data, and we integrate data that we collect to do something. And what we do with it is to develop some algorithm for prediction. We do some correlation between different kind of parameters to be able to have information on specific questions. And what we see, we need to have some standardized data. We need to have some precise data depending on the question. So in the framework of global warming, and we want to observe some small variation, tiny variations. And that's only possible if we have some precise tools. And that's, for me, in my opinion, some different question by comparing what's existing in the past compared to now, and the information we get now that we want to forecast for the future. And I think it's good to have, and it's really valuable to have data from the past, and it's good to have some really precise data. Getting no data is the worst. Getting good data is good, and gets a lot really accurate data is definitely the best.
Brilliant. Well, I think we must bring this track to a close. And I have to say, I've just thoroughly enjoyed the last hour and a half. And thank you both very much indeed for such fascinating presentations. Maxime, I thought your case studies from the aquaculture sector, showing what can be done with the sorts of data sources that are being created by technology, but also by data master planners like the eModNet team, was really illuminating. And Kate, my takeaway from you is my favorite one, which I've used many times, which is let's get out there and gather the data. Let's gather it once. Let's use it as many times as possible by as many stakeholders for as many purposes, and plus a lot of purposes we haven't even thought of yet. And let's use it to get the socioeconomic benefit we need from the seas and oceans, but let's use it to understand what we've done to our seas and oceans and what we need to do and fix them. So thank you both very much indeed, and also to James from Oceanology International for helping us to set this presentation together. Unfortunately, we have a virtual audience that isn't here yet, so you'll just have to put up with me giving you the round of applause, but I think you've both been brilliant. But were we there face to face, I'll be able to have a cup of coffee with you afterward, and thank you very much indeed. So with that, we'll close.